And welcome to this solution video. If you like it, please give it a thumbs up, share with your friends, and subscribe to Math United. Let's start with question number 1. Question number is asking us to solve this equation, and our answer should be in 4 decimal places. Since this is an equation which has a natural log part and a constant, in such cases we should always try to separate the two. So I wrote the first part and I took that 3 to the other side, it became minus 3. The reason for that is that if we remove this natural log from one side, which I'm doing now, the other side will become the power of e. Whenever natural log is removed from one side, the other side becomes power of e. And now it's a constant. Yeah, it looks like it has an alphabet e, but overall it is a constant because e has its own value just like pi. Okay, so what will we do? I'll just keep the variable part here, and this one will come to the other side. Okay, now this minus must go before I take care of this minus 2x. So I will do what? I will multiply the whole equation by minus 1 so that this becomes positive. So it becomes e to the power minus 2x equal to this minus 1 will become positive. So 1 minus this will become negative. So it's clearer now. Next step is that I get rid of this e. So when I removed natural log from one side, the other side became e to the power. When I will remove this e to the power, that means I will just write minus 2x. The other side will have natural log, obviously. Okay, and finally I need to get rid of this minus 2 so that x is left alone. So I'm dividing by minus 2 here, I'm dividing by minus 2 here as well. So minus 2 cancels. X is equal to minus half natural log 1 minus e to the power minus 3, which every part is a constant. Just put this in a calculator and you will get your answer. Let me try mine. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting from my calculator is 0.0254 decimal places they said. There are more digits after this, but this is what I will stop with. In question number 2, they have given us a mixture of x and y's, and they're asking us to find the gradient of the curve. And gradient of curve is nothing but of curve is same as gradient of tangent at that point, which is same as dy over dx, differentiation of the dependent variable with respect to independent variable, dy over dx. So we have to find dy over dx in this. Since it's a mixture of the two, we'll have to carry out implicit differentiation. Okay, in that what do? We treat y also as a normal variable like x and differentiate y like x, but whenever we differentiate y, we give it a suffix which is dy over dx. What I mean to say is this: x and y square are multiplying, right? So if I use product rule in this, because they are multiplying, I'll use product rule. So what will I do? I will differentiate x, but I will not differentiate y square, plus I will differentiate y square but not x. So that's product rule for these two because they are multiplying. Here the natural log is the only one, even though it has two things inside, but it is the only one term. So whenever we differentiate a natural log, we reciprocate what is the content of natural, which is x plus 2y. I reciprocated that, but due to chain rule I have to differentiate what is inside also. So what is the differentiation of x plus 2y? The differentiation of x is 1. Differentiation of 2y will be 2. Yeah, because the differentiation of y is 1, huh? Just like the differentiation of x is 1, differentiation of this y is also 1, but because we have 2, we'll write 2. But since we have differentiated y here, we will write dy over dx. So this part is also differentiated. Now differentiation of 1 is 0 because 1 is a constant. So let's do this product rule here. So the differentiation of x is 1, I'm not writing it, just y square. Plus differentiation of y square will be 2y, and we already have an x here, that's it. But we differentiated y in this case, so just like this one, we will write dy over dx. We'll suffix this with dy over dx because y was differentiated. Plus, now let me open this bracket. So I'll multiply with 1, this thing first. So it will be 1 over x plus 2y plus 2 over x plus 2y dy over dx equal to 0. Next step in this case should be that dy over dx, the terms which are containing dy over dx, will take it common from the 2. Okay, and write the remaining. So what do we are left here? 2xy. What is left in this one? Plus 2 over x plus 2y. Okay, remaining part will remain whatever that is. On the right side it will go. So y square is alone, it will write minus y square here. And then 1 plus this minus 1 over x plus 2y. Both of them were positive. They became negative, nothing else left. And our purpose here was to find the gradient of curve. So gradient of curve is this. So what will be dy over dx then? It will be this part, which is minus y square minus 1 over x plus 2y divided by whatever was multiplying with dy over dx. Because it's multiplying here, it will divide to the other side. It looks very odd, but if you keep your cool, everything will be okay. We should not worry how it is looking, because our question is not that we should simplify this. We don't have to simplify this. We have to find gradient. That is our aim when x is 0. So if it is look odd, no problem. So let me finish it here. When x is 0, substitute every x by 0. But what do we do with y? Okay, so we'll do what? First, from here we'll find what is y if x is 0 in this one. So let me use this space. So this x is 0, so 0y square plus natural log 0 plus 2y equal to 1. Yeah, from main equation I will get y. So 0y square is 0, natural log 2y equal to 1. So 2y equal to e, yeah, because if I remove natural log from here, the other side becomes e to the power. So it will become e to the power 1, but I'm not writing 1, so it is just e. Y is e over 2. So we got y as well. So when x is 0 and y is this, what will be dy over dx? And we will just write it here, dy over dx, which is gradient of the curve at x equal to 0, will be minus y square no, minus is not part of it, so I'll have to get rid of brackets. Only e over 2 will be squared because it is positive e over 2, right? This minus is part of the differentiation. Minus 1 over x is 0, so I will not write 0, I will just write 2y, which is 2e over 2. Let me cancel this to make it simple. Next, 2xy, 2 times 0 times y, so this is 0, whole of this useless, plus 2 over 0 plus, I'm not writing 0 again, and this will be 2y again, this 2y, It will again be 2 over 2 times e over 2, and this x cancels again. So yeah, now what do we need to do? Just simplify this. What are they saying? Find the gradient. They did not ask us to give in decimals. That means we will leave it as a particular exact form. So minus e over 4, if I open this bracket, minus 1 over 2, 1 over e, yeah, minus 1 over e. Okay, divided by, this is gone, 2 over e, yeah, yes, I've not made any mistake. So now let me try to make it simpler. So minus e square over 4 minus 1 over e is the numerator. Can I write it divided by this 2 over e? So multiplied by e over 2. When we convert a division into multiplication, the one which is dividing it reciprocates. That's what is happening here. So let's write it by expansion of, let's multiply this with e square over 4, that becomes minus e cube over 8, and e cancel here, so it will be minus half only. That's it. This is the gradient of the curve. Three. This question talks about an Argand diagram, which is this, and they're asking us find two inequalities in terms of z that define the shaded region. So the shaded region is this, from this straight line to this arc. Yeah, this is the area they're talking about. Okay, so we are seeing that it is being shaded below this line. Can you see? So what is this line? What is the equation of this line below which it is being shaded? That is one of the inequalities. And we can see that this is the imaginary axis. So we write imaginary axis of z, or imaginary part of z, less than minus 1. Is it equal to? Because it's a solid line, it is equal to also. If it was a dotted line, we would not write equal to, but if it is a solid line, it is equal to. That is one of the inequalities. They're saying two inequalities we have to write. Second inequality is that this shaded region is within this circle. So it is the intersection of this inequality and the inequality I'm going to write. This is the center of this circle, right? That means the z is somewhere on this circle's circumference. Suppose this is z. So I have to write as inequality that is some units away from the center, which is what? Minus 2 plus I. Z is how many? Okay, this will give us the measurement. This is exact. So 1, 2, 3 units. Z is 3 units away from minus 2 plus I. That is the equation of the circle. Because the shaded part is inside the circle, we'll write less than. So we'll write that z is the modulus of z. Okay. Let me undo this. Yeah. Modulus of z is z from minus 2 plus I is less than or equal to 3. Again equal to, because it's a solid circle. So z anywhere on this is 3 or lesser. So here z is 3 or lesser. Z is 3 or lesser. And the common part with this first inequality is this minor segment. And these are the two inequalities you had to write for these 3 marks. Okay. Now next question is find the greatest value of z, modulus of z, for points in this region. Means the modulus of z should be maximum. So from where? It will be from 0. Our always reference point is what is after z. There's nothing after z here, so I'll write z minus 0. That means we are talking about origin. From origin, we should have the maximum, what? Maximum distance of this in this shaded area. So let me draw a line from this. So no, it is not starting from the right one. Okay, it's starting from. So this is very short line. It is longer, longer, longer. In this shaded region, where do I get the longest line? Longest I get here. This is the longest modulus in this region from z minus 0. That is the requirement. So I'll find the modulus of this line, and that will give me the greatest value of modulus of z. To find that, here's my plan. I will draw this isosceles triangle, which is the center is this one, minus 2 plus I. I'm drawing it separate because it will be clearer here. Okay, we know that this distance is 2 units. Can you see? From the center to this line is just 2 units. We know this radius is 3 not centimeters, 3 units. Can I find this particular part? I can, right? Similarly, I can find this particular part also. This is also 3. So if I know the coordinate at this particular point is minus 2, if I find this length somehow, I will just subtract it from minus 2 and I'll get that one. Okay, and then once I get this one, I will just use Pythagoras theorem in this and I'll get it. Okay, so let's do it. So let's call this one as x. Okay, so 3 square is minus 2 square will be x square, and 9 minus 4 is 5 equal to x square. That means x is square root 5. So we got this as square root 5. So the coordinate we were looking here, which was minus 1, was the y coordinate, and what was the x coordinate or the real coordinate? It is minus 2 minus square root 5. Minus 2 minus square root 5. And now we'll use distance formula to find the distance we want from 0, 0 to this particular point, because we know this length now. We know this length already. We can just use distance formula because 0, 0 is useless in this case, and we can just find the distance. So let me do that. Modulus of z will be minus 2 minus 5 square minus 2 minus square root 5 minus 0. If we want to subtract 0, it is useless here, but yeah, that is the one, plus minus 1 minus 0 square, minus 1 minus 0 square. So I'm doing it manually. You can just place this in a calculator, you'll get it. So it will be how much? 4 plus 5 plus 4 square root 5. That will be the expansion of this. And minus 1, oh, I forgot square here, e plus 1. Okay, if I put this in my calculator, this is the actually 4 plus 5, 9 plus 1, 10 plus 4 square root 5 is the exact value of the modulus of z. And if you want to convert this to decimals, let me convert it. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 4.3525. Okay, 3 significant figures, 4.35. You write this or this is the same thing. This is the greatest modulus of z from origin. Number 4, by first expressing the equation this as a quadratic equation in tan x, that means it should have the powers of tan. Solve the equation for 0 to 180 degrees. So set up your calculator degrees and do this. All right. So first I will apply the identity which is available in your formula sheet, tan a minus b here, which is tan a minus tan b over 1 plus tan A tan B. Okay, so I will apply here. According to this, it will become tan x minus tan 60 degrees, that is over 1 plus tan x tan 60 equal to cot x. Cot x is the reciprocal of tan. So I'll write 2 over tan. Some people make this mistake that they will write 1 over 2 tan x. See, 2 is not being reciprocated. Only cot will be becoming 1 over tan. So 2 will remain the numerator. So this is a general tendency which you should avoid all the time. Okay, now cross multiply this here and this will go that side. So tan x multiplies with the numerator here, which is tan x minus tan 60. Let me write the value of tan 60, which is square root 3. Equal to 2 will multiply with this 1 plus tan x tan x tan 60 becomes square root 3 tan x. Okay, now let me bring everything to the left side and hopefully it will become a quadratic equation as they want. So it is becoming a 1. So tan square x, when tan and tan multiply, minus square root 3 tan x minus this 2 comes here, becomes a negative, and minus 2 root 3 tan x equal to 0. Nothing is left on the right side. So this and these are like terms, both are negative, so it becomes tan square x minus 3 square root 3 tan x. Because the variable part is same, so we'll just add minus square root 3 and minus 2 square root 3, which gives us this minus 2 equal to 0. Let me use quadratic formula for this. So minus b, this is b for me, so minus 3 square root 3 plus minus square root 3 square root 3 square. Let me put negative also, it doesn't make any difference. B square minus 4 a c divided by 2 times a, which is 1 in this case, and this will be equal to tan x because I have taken tan x as the variable, the whole of it. Okay, so this becomes how much? Positive 3 square root 3 plus minus 9 times 3 27 plus 4 times 2 8. Okay, over 2. All right, so it comes out to be two answers: 3 square root 3 plus square root 35 over 2. Second answer is 3 minus 3 square root 3 minus square root 35 over 2. If I convert them to decimals, this comes out to be 5.556, more digits, and this one negative 1 comes out to be negative 0.3599. Okay, and now since this is negative, this is positive, we have to look for the answers between 0 and 180. So tan is positive here and negative here. So we'll take this positive one, whatever angle it gives in this acute, the first quadrant, and that will be the answer. So x in this case is tan inverse 5.5561, which comes out to be 79.797. So I will write 79.8 degrees. That is first answer. This one gives us x equal to tan inverse 0.3599. Why did I ignore this negative? Because I already know that angle will be in this second quadrant, and accordingly I will choose my answer. So it comes out to be 19.796. 19.796. So let me write 19.8. But this is not the answer, right? because in second quadrant we got the acute angle. We will draw that angle here with the horizontal line, always with horizontal line, 19.8 degrees. But our answer will start from 0, and this will be our answer, which will be 180 minus 19.8, 160.2 degrees. So we got two answers, 160.2 degrees and 79.8 degrees. These are the two solutions of this particular equation. 5. The square roots of this particular complex number can be expressed in this format where x and y are real and exact. So minus 4 plus 6 square root 5i. This is, it's a square root is in this format. So that means this is the square of x plus iy. Yeah, because square root of this is x plus iy. So if I square it, that will give me this. That's straightforward. Okay. So let me open this side of the equation, which will be a plus b square I will use here. So a square plus b square plus 2ab. So 2x iy. This is the square of this particular part, which is equal to minus 4 plus 6 square root 5i. Okay. So it becomes x square. But this will become I square y square, right? This one. And I square is negative 1. So I can write negative 1 in place of y square. Sorry, I square, and y square will remain y square. Plus 2xy I. This is equal to minus 4 plus 6 square root 5 I. Now we know that the real number cannot become imaginary and imaginary part cannot become real. That means this minus 4 has to be equal to this real part. So x square minus y square is equal to minus 4. This is our one equation. Second is that this imaginary part, which is 2xy I, has to be equal to 6 square root 5i imaginary. So we can ignore imaginary part in this, and we can get a relationship from here, which is I will substitute x. So I will isolate x on this one, will be equal to 6 square root 5 over 2y. I'll cancel 2 and 6. So it becomes 3 square root 5 over y. Okay. And now I'll substitute this in the equation I got in the real part, which is 3 square root 5 over y square, because x is this. X is this. But y square remains y square minus equal to minus 4. Alright, so they wanted quartic. We'll get quartic how? 9 times 5, 45. This is square of 3 square root 5 is 45 over y square minus y square equal to negative 4. To get rid of this this y square, I'll multiply the whole equation by y square. So when 45 over y square is multiplied with y square, we are left with just 45. When y square multiplied with y square, we get y to the power 4 equal to minus 4y square. And let's arrange this now. Y square, I'll take the other side, minus 4y square will remain minus, but this 45 will also become negative. 45 is equal to 0. This is the quartic equation they were asking for in terms of x or y. So we got in terms of y. And now we have to find the roots of this, and we'll choose the real ones, which will be take the place of x and y. Okay. And I made a mistake here. It should be y to the power 4. Okay. So let's assume, let y square is equal to t. So this quartic equation becomes quadratic. T square minus 4t minus 45 equal to 0. And you can solve this by whatever method you know. Let me split the terms here. Middle term, t square minus 9t plus 5t minus 45 equal to 0. What I get is t minus 9. Or let me not do shortcut. Let me show you how I got this. So I'll take t common from these two terms. The first two terms, t taken common, so I'll be left with t minus 9. Take 5 common from here, I'll get t minus 9 again. So I get t plus 5 and t minus 9 equal to 0. Okay, so t was y square. So y square plus 5 equal to 0 or y square minus 9 equal to 0. So this gives us y square equal to negative 5, which is not possible. Why? Reject this. Because a square number cannot be a negative one and they wanted only real ones. I reject this. So y square equal to 9, and if I square root both sides, I get plus or minus 3. So I get two values of y and I'll get the corresponding values for x in this case. So y equal to 3 is 1, y equal to minus 3 is 1. What about x? And x was 3 square root 5 over y. So x equal to 3 square root 5 over y. I got square root 5. And here I'll get x equal to 3 square root 5 over minus 3 minus square root 5. So final answers, here I got x plus iy they wanted. X is square root 5 plus iy and minus square root 5 minus iyi. These are the two square roots of the given complex number. Talks about differential equation. This we have to solve it. We have been given this information to find the value of c. So the first step of solving any differential equation is that both dx and d theta or whatever that are there in the differential equation, they must be numerators. Dx is a numerator, so I will write it like this, dx. If I want to make this d theta the numerator, I'll cross multiply to the other side. So I will write equal to, and I will write d theta with some space. Second requirement is that dx should be accompanied by the part which has x in it. So this part has x in it. It should go to the other side, but since it is multiplying here, it will become a denominator here. So can I write 1 over 5? I'll write this as 0.2 so that it looks easier to understand. Plus 1. 0.2 x plus 1. So 1 over 5 converted to 0. So it becomes simpler. It's not a fraction inside a fraction. That's why I'm doing this. Sine square 2 theta stays where it is because d theta has come over here. So sine square 2 theta. Now, to solve a differential equation, third step should be that we have to integrate both sides. And we have to integrate them separately with respect to their variables. Dx here and d theta here. This is a linear denominator here. So if I integrate this, I'll get a natural log of 0.2 x plus 1 divided by differentiation, not integration, of the content of the denominator which was there. So differentiation of 0.2 x plus 1 is 0.2. That's it. The left side is done. Second one, there is no integration direct for a square. So what will we do? we'll use this identity to integrate this one. The identity in your formula sheet will be, there are three options for cos 2a, but I'm choosing the one which has sine square in it because our question is about sine square. So if I rearrange that, I'll bring 2 sine square theta here, and I'll be getting cos 2a will come to the right side, becomes negative. And to remove this 2, I'll divide the other side by 2, cross multiply. So sine square a can be substituted by 1 minus cos 2a plus 2. But in this question, angle is not a, angle is 2 theta. Accordingly, I will write 1 minus integration of 1 minus cos 2, and in place of a, I'll write 2 theta here. Divided by 2 d theta. Or let me undo this and write this divided by 2 outside so that it does not disturb. Let me write here. Yeah. So I will write 1 over 2 outside. That is equal to divided by 2, right? So that I am just left with cos 4 theta d theta here. Why 4 theta? Because 2 is here in the identity and 2 theta was the actual angle. So double of 2 theta is 4 theta. Alright. Let me write this now. 0.2 is 1 over 5. Yeah. So if something is divided by 1 over 5, that means it is being multiplied by 5. So denominator of a denominator is numerator. So I'm back to the fraction so that I converted decimal not to have any confusion about it. Now since I can make it a normal expression again, so I've done that. So now the integration of 1 will be theta minus integration of cos 4 theta will be positive sine 4 theta, and negative will stay negative, that means. So it will be sine 4 theta over 4 plus c. So half multiplies with both of them because there was a bracket around it, and c I wrote outside. Okay. So let me write here natural log of 1 over 5x plus 1 to the power 5. Isn't it? I can make this coefficient as power, and then I'll separate this. This becomes half times theta is half theta. Half times this will be minus 1 over 8 sine 4 theta plus c. Now we will use the information they've given, x equal to 5, theta equal to 0. So when x is equal to 5, theta is equal to 0, that will give us the value of c. So I'll write here natural log 1 over 5 multiplied by 5 plus 1 to the power 5 equal to half times 0 minus 1 over 8 sine 4 times 0 will be 0 plus c. So sine 0 is 0, so this whole thing is gone. 0 times anything is 0, this is also gone. So c is equal to whatever comes out here. 5 and 5 cancel. So natural log 2 to the power 5 equal to c. 1 plus 1, 2, yes. Which we can write as 32. c equal to natural log of 32. 2 to the power 5 is 32. So we got c also. What is our final equation now? Solve the differential equation, obtain an expression for x in terms of theta. That's what I need to do. So I'll first write what I got here, rather this one. Okay. So natural log 1 over 5 x plus 1 to the power 5 equal to half theta minus 1 over 8 sine 4 theta, and I just got natural log 32. Okay. My target is to isolate this x because they want x in terms of theta. So this x has to be isolated. So what will I do? I will remove this natural log first. When we remove natural log from one side, as we did from previous questions also, we apply e to the other part. That means the whole of it becomes the power of e. So it will become 1 over 2 theta minus 1 over 8 sine 4 theta plus natural log 32. Okay. Now, since this phi will be creating trouble to isolate this x, so we will do what? We will give whole of the both sides a power of 1/5. That is allowed. We can do that. So, let me make some space here. 1 over 5, this side also. So, this 5 and 1/5 cancel. So, 1 over 5x plus 1 is equal to e to the power 1 over 10 theta, then minus 1 over 40 sine 4 theta plus 1 over 5 natural log 32. Since they are all powers of e, we can separate them. So 1 over 5x plus 1 is equal e to the power 1 over 10 theta minus 1 over 40 sine 4 theta multiplied by e to the power 1 over 5 natural log 32. Okay, so now this one has to go. First of all, this e has to be, okay, let's do this. 1 over 5x, and I'll take this 1 to the other side. E to power 1 over 10 theta 1 over 40 sine 4 theta. Why did I separate these two? Because they don't have natural log. This has natural log, that's why I've separated this. E to the power natural log 32 to the power 1/5, and this plus 1 will come to the other side, minus 1. So it comes out to be 1 over 5x equal to e to the power 1 over 10 minus 1 over 40 sine 4 theta. And here natural log and e will cancel out each other, and 32 to the power 1/5 is just 2. That 2 I will write in front, minus 1. And final answer should be this. This 5 will also go, so that my x is left alone. So x will be equal to 5 multiplied with 2, we get 10. E to the power 1 over 10 minus 1 over 10 theta minus 1 over 40 sine 4 theta minus 5, because this 5 will multiply with this 2 as well as minus 1. They are subtracting, so both of them should be there, and this is our final answer. Here we have been given a graph of this function from 0 to 1 over 4 pi. The curve has a maximum point at m, where x is equal to p. Show that p satisfies this equation. Since m is a maximum, that means it is a stationary point. Yeah? And what is special about stationary points? Stationary points have a gradient 0, which means dy over dx is equal to 0. That's what the gradient is. Gradient of a tangent or the curve is at m, right? So we will first differentiate this, and then we'll substitute x equal to p, and we should get what they want. So let me do it here. Dy over dx equal to x cube and cos 2x are multiplying, so we'll use product rule. First we will differentiate x cube, but we will not do anything with cos 2x. That's the product rule. Then we will differentiate cos 2x, and we'll keep x cube as x cube. That's product rule. And the differentiation of x cube is 3x square cos 2x. The differentiation of cos 2x will be minus 2 sine 2x by chain rule. First we'll differentiate cos 2x and then we'll differentiate the angle multiplied by x cube. And let's put this in bracket. It is different from the angle. Okay, that should not confuse. So x square is common here and here as well. So we'll take x square as common. So 3 cos 2x is left here. And here out of x cube, x square is out. So x square minus 2x sine 2x. This is dy over dx. This has to be equal to 0 for a stationary point. That's what we decided. X square, there are two possibilities. Either x square is 0 or this part 3 cos 2x minus 2x sine 2x equal to 0. Either this or this. There are two options. X is 0 is clearly a stationary point. We can see here at 0 the graph is turning maybe after this. So this is of no use. We want a number which is positive, which we'll get from here. And our target is to get this. So first we need a tan angle. So sine over cos will be tan. So let's put them to let's divide them by cos 2x. So I'm dividing this by cos 2x here. I'll divide this one also by cos 2x, and there is nothing in between. They're separated. We can do that, right? And if I divide 0 by cos 2x, it will be 0. So I'm not doing on the right side. It is 0. It will ultimately will be 0. Cancels. 3 minus 2x tan 2x equal to 0. We need p as a subject. So we will substitute x by p because x is p at this m value. So at m x is equal to p. So let's bring this one to the other side. So 3 equal to 2p tan 2p. Okay, so I brought this to the other side and substituted x by p. Now this 2p will come to the other side. It will become 3 over 2p equal to tan 2p. Now I will bring tan to the other side. It becomes tan inverse 3 over 2p. Is it matching? Yes, it is matching there. Equal to 2p. And if I isolate this p, I'll divide both sides by 2. This 2 cancels, so p is equal to half tan inverse 3 over 2p, which is this. We got it, what they wanted. They have a b part also, which says show by calculation that p lies between 0.5 and 0.7. Okay, so in this case, what do we do? That we use this one. Let me repeat that one. P equal to half tan inverse 3 over p. Whenever we have combination of an algebraic or an inverse or any two types of expressions in one equation, we put all of them to one side. So it will become p minus half tan inverse 3 over 2p equal to 0. That means the solution of this particular equation is left side is equal to 0, right? So if I have to prove that that value lies between 0.5 and 0.7, I will substitute these two values in this equation and they should come around 0. Okay, so let me substitute them one by one. So I will substitute first when p is equal to 0.5, this first limit. So it will be 0.5, this p I substituted by 0.5 minus half tan inverse 3 over 2 times 0.5. Okay, it will give me some value which I'll find out together with the other one, and when p is equal to 0.7, so it will become 0.7 minus half tan inverse 3 divided by 2 times 0.7 equal to. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is minus 0.1245, and I'm getting here 0.1329. The most importantly, one is negative, one is positive. We wanted this expression to be equal to 0. So if we draw any graph and we want to find a root which is x-intercept, right? If one side is positive and the other side is negative, that means 0 is somewhere in between. So if this is negative here and positive here, that means our actual answer is between 0.5 and 0.7. And how do we write this final statement here? We write that the change in sign indicates the presence of root between 0.5 and 0.7. That's what they were asking us to show. Alright, do we have another part? Yes. Use an iterative formula based on the equation part A, which was this one, p equal to half tan inverse 3 over 2p, and we have to give p correct to 3 decimal places, and result should be, okay, each iteration should be in 5 decimal places and the answer should be in 3 decimal places. Okay, so let me do them one by one. So our main equation was p equal to half tan inverse 3 over 2p. Now we already know the answer lies between 0.5 and 0.7. So we can take a number which is exactly between them, 0.6. If you take 0.58 or 0.65, that is also fine. We'll finally get to the answer. But since we are not aware what is the exact answer, it's safe to start from the middle. Okay. So what will I do? I will write this one as Pn plus 1, and this will become Pn. This is how it becomes an iterative formula. So Pn plus 1 will be P2 for my starting half tan inverse 3 over 2 times P1, because if n is 1, this becomes 2. So P1 I'm starting with 0.6, which is exactly between these two numbers. So I will start with 0.6. Okay, and I will get some value from here, and that iteration, they said we need to write it from 5 decimal places. We have to write each iteration 5 decimal places. So first one comes out for me 0.59514. Okay, P3, I'll go to the next one, and this time P2 will become the content of this. So tan inverse 3 divided by 2 times 0.59514, 5 decimal places. Okay, and if I use my calculator, I get 0.59654. What should I do whenever I write 5 decimal places iteration? I should round them off to 3 decimal places, so that if 2 consecutive places we have exactly same value, that will be our answer. So if I round it off to 3 decimal places, it will be 0.594 5. This one will be 0.597. So they are not equal. I'll keep on doing it until this happens. So I'll fast forward this particular part of the video, and then when this video will be resumed, you'll see my answer. Okay, so I already got my answer here. Two consecutive iterations were rounded out to 0.596. So that gives me the answer. P equal to 0.596. Is on vectors, and they saying that these two lines are skew lines. Show that. Skew lines means two lines which are going over each other, right? But they are on different planes, so even if they are crossing below each other, but they are not actually intersecting. That means they do not have any point which is common between the two. Okay? So such questions we start assuming that they are intersecting. If they are intersecting, there will be a point which will satisfy both the equations. Yes? So what is the general point on the first line? So let me say line 1. Okay? The points on the line 1 will be minus 1 plus lambda 2. Minus 1 plus 2 lambda. This will be the x coordinate of that point. 3 plus 3 lambda will be the y. And minus 4 minus lambda will be the z1. In L2, the same point, if they are intersecting, what will be the point? 2 minus mu rather, 2 minus mu, minus 3 minus 2 mu, minus 1 plus mu. Okay? So, if two lines intersect, their coordinates will be same. The point of intersection coordinate will be same. That is minus 1 plus 2 lambda has to be equal to 2 minus mu, or 3 plus 3 lambda has to be equal to minus 3 minus 2 mu. So let's rearrange this and bring mu to the other side. It becomes 2 lambda plus mu equal to 2 plus 1, 3. What does this give us? 3 lambda plus 2 mu equal to minus 3 minus 3 minus 6. Okay. Now we have two simultaneous equations, and they will definitely give us some answer. So I'll multiply this by minus 2, this equation by minus 2, so that I can becomes negative 2 mu here. So it becomes 4 lambda, this equation becomes minus 4 lambda rather, minus 4 lambda minus 2 mu equal to minus 6, right? So I need to change the sign now. It comes out to be how much? Plus, no, I have to add them. I don't have to subtract them, so no plus. So 3 minus 4 lambda will be minus lambda. They will cancel out while adding 2 mu minus 2 mu. That was the purpose. That's why I multiplied by minus 2 equal to minus 12. So lambda comes out to be 12. What about mu? Let me use this part to find mu. So mu equal to 3 minus 2 lambda. 3 minus 2 lambda. So mu equal to 3 minus 24, which is minus 21. So mu came out to be minus 21, lambda it came out to be 12. That does not mean that this intersection point actually exists. Any two simultaneous equations will give you some values. So we are not there yet. How will we prove that they are skew? If this minus 21 and 12 works with the third part, which is z coordinate. Yeah. So minus 4 minus lambda, lambda is 12, has to be equal to the minus 1 plus, which is minus 21. Mu is minus 21. So it becomes minus 16 and this becomes minus 22, which are not equal. So you write, since z component or z coordinate, if you want, right, z component did not satisfy the condition of intersection the two lines are skew. Okay. Question number B part of this. Find the obtuse angle between directions of two lines. Alright. So you may be thinking, two lines are not intersecting. How can we find angle between them? So you must know that in a 3D space, if they are not intersecting, this goes below the other line. Even then, we can see from top that they are making some kind of angle. They are not intersecting, but still they will be making so an angle which is actually crossing the lower line, and if it is in same direction and same magnitude, so we can say that they are making some angle. Okay, and that angle has to be obtuse angle. That's what they're saying. Okay, so we will find the obtuse angle between the directions only, not this position vectors which we use for points on that line. Okay, we will find the angle between only the direction vectors, which is 2 3 minus 1. So let me write 2 3 minus 1 and minus 1 minus 2 minus 1. Okay, first is 2 3 minus 1 and second one is minus 1 minus 2 and 1. We need to find the obtuse angle between these two vectors. Okay, so the angle formula for the angle is theta equal to cos inverse A dot B over absolute A absolute B, which means the dot product of the two vectors, which are these vectors. So I will write theta equal to cos inverse, the dot product of these two vectors will be x dot x1 dot x2, which is 2 multiplied by minus 1, then 3 multiplied by minus 2, and then minus 1 multiplied by 1. This is A dot B. This is how we find the dot product of two vectors. Just multiply x components, y components, z components individually and add them. Now I need the magnitude of the first one, which will be 2 square 4, 3 square 9 and minus 1 square 1, multiplied by minus 1 square 1, minus 2 square 4 and then 1. If you can put the whole of it into your calculator, good. Otherwise, let's write the simpler version of this, which is minus 2 minus 6 minus 8 minus 1 minus 9 over 13 plus 1 square root 14 and 1 plus 4, 5 plus 1 6. Since this is a negative inside, obviously it will be an obtuse angle, because we know that the cos is positive in first quadrant and negative in second quadrant, and second quadrant is nothing but obtuse. Just put this in a calculator and you get your answer. By the time I do this in my calculator, I would request you to like this video, share with your friends and subscribe to Math United. What I'm getting here is 169.1 degrees. There are 4 significant figures, but in angles we always give answer in 1 decimal place for degrees. This is our answer. They're asking us about this polynomial where a and b are unknown. It is given that x minus 3 is a factor of this. So using remainder theorem, we assume that if x minus 3 is equal to 0, if a factor is 0, the polynomial will be also 0. Alright? So x is equal to 3, that means P3 has to be equal to 0. So we'll write P3 now. Substitute every x by 3 plus a 3 square plus b 3 plus 9 has to be equal to 0. So it comes out to be 27 times 6, 162 plus 3 square is 9a plus 3b plus 9 equal to 0. So I can write 9a plus 3b equal to 162 plus 9 is 171. When it goes to the other side becomes negative 171. I think 7 plus 1, no. Yeah, all of them are divisible by 3. So let's divide whole of it by 3 so that it becomes an easier equation for us. So it becomes 3a plus b equal to 5, 21, 7, 57. This becomes equation number 1. What about the second one? They said, and first derivative p prime x, if it is divided by x minus 3, the remainder is 72. So p prime x, we have to differentiate the given function first, which is 3 times 6, 18x square, 2 times a, 2ax, and bx, the differentiation will be just be differentiation of 9 is 0. So this is our p prime x, the differentiation of the polynomial. Now they're saying when x minus 3 divided by x minus 3, that means again we will substitute 3 here. So p prime 3 will be 18 times 3 square plus 2a times 3 plus b is equal to, how much is the remainder? 72. Hopefully this will give us another equation, which is 18 times 9, 162. Let me bring 162 to the other side. So 72 was already there, 162 came in negative. Okay, it becomes 6a plus b. This is equation number 2. Now I have to, okay, both are b's, so we can simply subtract. So I'm writing that equation here, equal to minus 57, and I will subtract this time. I'll change this sign, and change this sign. This cancels out because of the opposite sign. 6 minus 3 is 3a equal to, so 57 plus 72 will be 129, and this divides here 162, 33 and negative 33. So a comes out to be negative 33 over 3, which is negative 11. What about b? So let's substitute b here. 3a here. 3 times minus 11 plus b equal to negative 57 minus 33. So it becomes positive 33 when it comes to the right side, and b comes out to be negative 24. What is the question? Find the values of a and b. We got both of them one by one. Okay. When a and b have these values, okay, found in part A, factorize polynomial completely. So I'll have to copy the polynomial first, and the polynomial, what was that? I'll have to copy it here. I have to factorize this. So 6x cube ax square, a is minus 11, so minus 11x square plus bx, which is minus 24, plus 9. We have to factorize it completely. It's a cubic function. and we know that x minus 3 is already a factor. They have already said that x minus 3 is a factor. So if I multiplied by, not multiplied, divided by x minus 3, the quotient I will get will be the other factor, right? So my job will become easier if I divide it first. So let me divide. 6x square, I find right at quotient, so it will be 6x cube here, minus 18x square, and we should be aware that the answer remainder of this division must be 0, then only x minus 3 will be a perfect factor. So it comes out with 7x square minus 24x plus 9. So I'll multiply x with 7x. 7x square minus 21x. This becomes positive, this becomes negative, cancel out. So it becomes how much? Minus 3 x plus 9. Now this x will be multiplied by minus 3 to be equal to minus 3x here, and minus 3 times minus 3 is positive 9. We subtract both by changing sign. Cancel, cancel. Yes, as expected, we have 0 remainder, but the job is only half done. We know x minus 3 is one of the factors. If we factor this quotient, we'll get the remaining factors. This thing factorize completely. So I'll factorize only 6x square plus 7x minus 3 only. Alright. So I can use splitting the middle term. Yeah. 6 times 3 is 18, and if I factor 18, 9 and 2 will give me 7. It is positive, so 9 has to be positive, this has to be negative. So splitting the middle term. 6x square plus 9x minus 2x, 9x minus 2x minus 3. I have not changed the expression, I have just split the middle term. The common between these two is 3x. So 2x plus 3. Minus 1 common in these two, 2x plus 3. So the 2 factor become 2x plus 3 is common between these two, remaining is 3x minus 1. So they wanted us to factorize it completely. So complete factors. It is x minus 3 was already known to us, this one. Second is 2x plus 3. And third one is 3x minus 1. We have factorized the polynomial completely. Hence, solve the inequality px is less than 0. Okay. Px is less than 0, that means the best part, because it may be of 1 mark or 2 marks only, the best way would be that we draw a graph for this. Okay. We will mark the 3 factors which will give us 3 x-intercept. This will give us x-intercept equal to 3. So let me write 1, 2, 3. This is our first x-intercept. This will give us, if I write 2x plus 3 equal to 0, 2x equal to minus 3, x equal to minus 3 over 2. So if this is here, minus 3 over 2 will be 1.5. So here, this is our second x-intercept. Third, this one will give us 1 over 3, positive 1 over 3, which is here. Now, how the graph will look like? Because it's a cubic function, it will start from the negative negative to, it will go to the positive positive. So our graph will be passing through this, coming back here, passing through this. This is how the graph will look like. It goes through these 3 x-intercept, starts with negative negative, goes into positive positive. Alright, but our question was px is less than 0 means negative, and px is what? The y value. Where is the y value negative? This is negative value, where x is less than this value, which is minus 3 over 2. So first answer is x is less than minus 3 over 2. No equal sign because there is no equal sign here. This is our first value, which gives us negative. Secondly, the y value is negative. Below x-axis is this. From, this was how much? 1 over 3? Yeah, this was 1 over 3 positive, and this was 3. So between 1 over 3 and 3 is our second answer. Yeah, these two areas, y value is negative. 10. Let fx be equal to this rational function. Express fx in partial fractions. So we need to just partially fractionalize this. Okay, so we'll do that. For that, I have to first check whether the degree of numerator is less than denominator or not. If it is, good. If it is not, then we have to do something. The degree of numerator is 2. Degree of denominator is 1 here and 2 here, total 3. They are multiplying, they will become a cube. So that's correct. The degree of numerator is lesser than degree of denominator. We are good to go. We can assume minus 7x square plus 2x minus 6 divided by 1 plus x 4 plus x square is equal to a over 1 plus x plus b over 4 plus, it is degree 2. Whenever we have degree 2 denominator, we have to write bx plus c, 1 degree lesser on top. C, not 6, c. Okay? Now, minus 7 x square plus 2x minus 6 divided by 1 plus x 4 plus x square will be a multiplies with the denominator of the other one, because it already have 1 plus x, so it will be 4 plus x square plus bx plus c multiplies with the denominator of the other term, which is 1 plus x, divided by, they both multiply, 1 plus x 4 plus x square. Both have same denominator, both sides. We can cancel out these. So we are left with only the numerators now. Now to find the value of a, b and c, we'll first assume that x is equal to minus 1, so that this bracket becomes 0. So minus 7 times minus 1 square plus 2 times minus 1 minus 6 equal to a 4 plus minus 1 in a bracket. Okay, keep in mind it should be in bracket, because the square is being applied with whole of x, and x is minus 1 including minus, so that has to be squared as well, plus b minus 1 plus c multiplied by 1 plus minus 1 is 0. That was the purpose, to make it 0. This whole term becomes 0. So we are left with only this, which is positive 1 times minus 7, 2 times minus 2, minus 1, minus 2, minus 6, equal to positive 1 plus 4, 5a. So it is 9 plus 6, 15, negative 15 equal to 5a. So a becomes minus 15 over 5, which is minus 3. Got a. Now for b and c, let's compare constants. Constants on both sides. What is constant in this side? Minus 6. Yeah? So we'll write minus 6 equal to. What will be the constant in this side? A times 4 will be constant. A times x square will not be constant. So I'll just write 4a. 4a, because I got a minus 3 here. What will be constant in this expansion? C times 1 will be the constant. Just C. So I compared constants. minus 6, and this is minus 12, becomes 12 here, equal to C. So C is equal to 6. Now we are left with B. We have to find B. For B, let's do a comparison of coefficient of x square. What are the coefficient of x square here? Minus 7. This is not, this is not. So minus 7 is the left side. Coefficient of x square here will be a x square. A x, oh sorry, we don't have to write x square because I did not write here. We are comparing only the coefficients. So minus 3 will be the coefficient of x square here. Here x square will be bx times x will be bx square. Yeah, that will be, the coefficient will be b, just b. So b we already know. Oh sorry, we don't know. We don't know b. So b is the only one. So this minus 3 goes to the other side, becomes minus 7 plus 3 equal to b. So b is also, no, it is equal to minus 4. Got a, b, c all. So the partial fraction which they were asking is this. A is minus 3. So I will write minus 3 later. If 1 over 1 plus x, right? A over 1 plus x, written this. B is positive? No. C is positive. So I'll write C first. C is 6. And then I'll write bx, which is minus 4x over 4 plus x square. And minus in between, I can ignore. Let me erase this. I can write minus in between here. This is the partial fraction. What next? Hence, find the exact value of this. Okay, so we have definite integral on our hands, and the basis is this, the integration of fx, which is this. So I will write it here now. Integration from 0 to 2 for 6. I'll separate these also. These two parts I can separate. So 6 over 4 plus x square dx. Then I'll write minus 4x plus x square, and then I will write dx minus 3 over 1 plus x dx. Okay, let's do them one by one, and I'll need some space for that. Let me use this right side of this. Okay, so I'll divide this into 3 parts. First I'll integrate this one in this one, which is, I'll not write the limits as of now. 6 over, okay, I'll write 6 outside. 6 1 over 4 plus x square dx. Second, I'll write 4 outside, x over 4 plus x square dx, and then I will write here 3. I'll take care of negative later. Okay, 1 over 1 plus x dx. This one is the easiest one because we have a linear denominator. It will be 3 natural log of 1 plus x. That's it, done. One step. Divided by the differentiation of the denominator, but differentiation of 1 plus x will be 1, so no need. This is the one for this one. This is also easier. How? If I somehow write 2 here and divide by 2 also. Did I change the whole? No. Because I multiplied by 2, I divide by 2. And why did I do that? Because the differentiation of 4 plus x square is 2x. So 4 divided by 2, 2. This becomes 1 over u du format. Whenever the numerator is a differentiation of the denominator, if you want to do substitution, so the whole process, I don't want to do that because it's understood. So if the numerator is differentiation of the denominator completely, we can write 1 over u du format, and it will be 2 natural log u, where u is the denominator. So it becomes 2 natural log 4 plus x square. This is also done. Okay. Now this one, 6. Can I write this as 1 over x square plus 2 square dx? I just changed their places because in addition we can. And 4 I wrote as 2 square. And if you look at your formula sheet, this is of the format x square plus a square. So its integration will be 1 over 2 tan inverse. Just look at your formula sheet, it has given it x over 2. So we have done all three separately, and now we will continue where they wanted us to do it here. So our combined integration becomes 6 divided by 2, 3 tan inverse x over 2 plus this plus, no, minus 2 natural log 4 plus x square, 2 natural log 4 plus x square minus, then we also have 3 natural log 1 plus x, 3 natural log 1 plus x. Okay, and plus c, and we have to write from 0 to 2. And now we'll substitute 2 and 0, and we should get our answer in this format. So I'll substitute 2 first. So 3 tan inverse 2 over 2 minus 2 natural log 4 plus 2 square, which is 4, minus 3 natural log 1 plus 2, and c I'm ignoring because it will cancel out later, minus 3 tan inverse 0, because x over 0 over 2 will be 0, minus 2 natural log 4, because x square will be 0, square will be 0, so just natural log 4, minus 3 natural log 0, 1 plus 0, 1, and close. Natural log of, and rather log of any 1 is 0, so this one is gone. We are left with rest of them. 2 by 2 is 1, tan inverse 1 is pi by 4, so it becomes 3 pi by 4, minus 2 natural log 8, minus 3 natural log 3, tan inverse 0 is 0, so this is also gone. This minus and this minus will become plus natural log. It is still far away from what we want here. Pi is okay, no need to change this one, 3 pi by 4. But these natural logs we can change. So I will write plus natural log a to the power minus 2, this minus 2 comes here, plus natural log 3 to the power minus 3, plus natural log 4 square. Why did I do that? Because these three natural logs can become one natural log only if the coefficients are taken care of, they are removed. And now this will be 3 pi by 4 plus natural log all three, because they are adding, they will multiply. So a to the power minus 2 times 3 to the power minus 3 times 4 square. So we can write this as 3 pi by 4 plus natural log. 4 square is 16. 8 square is 64, but because it's negative, it will become a denominator. And 3 cube is 27, it will also become a denominator. 16 times 4 is this. And this is in our format. A pi minus, because this is plus, we'll have to change it to minus. Okay. 3 pi by 4 minus natural log. How much is that? 27 times 4 is 108. To the power minus 1. Because I have made this minus, I have to put this minus 1. That means this particular fraction will reciprocate because of minus 1. So our final answer should be 3 pi by 4 minus natural log 108. So they wanted us to find A and B. A is 3 by 4 and B is 108. Done. 11 and the final one. Find the exact value of this integration. Again, another integration. Here two parts are multiplying and both have variables, so we'll have to do it integration by parts, where we follow this particular sequence: log, inverse, algebraic, trigonometric, exponential. We have one. This one is algebraic, this one is trigonometric. So algebraic will be taken as u and trigonometric will be taken as v prime. V prime. Okay, so let me write here. U is equal to x square. I'm assuming. Let u equal to x square and v prime equal to cos 1 over 3x. Okay. Now our product rule, if you remember, is uv. Differentiation of uv is u prime v. In your formula sheet, it has been written as d over dx. Okay, but I'm writing it in simpler form. So uv prime, right? Our question is uv prime. So uv prime, I will take this to the other side. So uv prime equal to uv minus u prime v. Okay, but our question is integration, so we'll integrate both sides. Okay, in integration, the differentiation and integration will cancel out each other. So we are left with uv minus integration of u prime v. That is equal to what our equation we have assumed to be, where u is x square and v prime is cos 1 over 3x. So our solution will be u first, u is x square, v is not here, so we'll integrate this and we'll get v. Integration of cos 1 over 3 x will be positive sine 1 over 3 x divided by 1 over 3. Divide by 1 over 3 means multiply by 3. So this is our v. So I will write 3 here and sine 1 over 3x. One part is done. Now here u prime, we have u but not u prime, so we'll write u prime also. Differentiation of this will be 2x. So 2x and v we just found out 3. Let me put it outside. 3 sine 1 over 3 x dx. Again two parts are multiplying just like this. That means we'll have to use this again. Okay, So we'll have to go in a different journey for this alone. That we can take care later, right? So what I'll do, I'll take this 6, 3 times 2, 6 outside, and we'll again use this u, v, and now our u and v will be different. Our u is just x because 2 I have taken with 6. So u is x. V prime. I'm not changing the alphabets because that is the habit we have. So sine 1 over 3 x. This is v prime. Okay. So again we need a u prime, which is differentiation of this, which is 1, and integration of this, which is v, which will be minus 1 over 3, not 1 over 3, positive. Let me undo this. Minus 3 cos 1 over 3x. This will be the integration of this. The integration of sine 1 over 3 is minus cos 1 over 3 divided by 1 over 3, which gives us 3. So this is the one. Alright, so uv, again uv. U is in this case x. V, we just got it, minus 3 cos 1 over 3x. Please put a bracket so that this is separated and show that they are multiplying, not subtracting. uv minus integration again. U prime, which is 1. No need to write 1. Just v, which is minus 3. So I'll write minus minus plus 3 cos 1 over 3 dx. Alright. So now we are done. 6 times minus 3 is minus 18 cos 1 over 3x. And now 6 times 3 is 18 again, but this time plus. And we had minus here. And we had a minus here. So this will become positive. We have to be very careful here. And this will become negative. Why? Because of this minus here. So minus 18, and then integration of cos 1 over 3, we did it where? Here. It is minus 3. So minus 3 sine 1 over 3x plus c. And before that we had this 3x square sine 1 over 3x. It was a definite integral from 0 to pi. So we will put 0 to pi. I hope I have not made any mistake in this one. So 3 pi square sine 1 over 3 pi, okay, plus 18 cos 1 over 3 pi. 18, just 18? No, it is x also. I forgot to write x. Okay, cos 1 over 3 pi minus this 18. This also has an x. Did I make a mistake somewhere? Okay, this one is same thing. Okay, yeah, it has to be 18x. Okay, minus this is 54 plus 54. Yeah, minus 18 times minus 3 sine 1 over 3 pi minus, put 0. Sine 0 is 0. That means no need to write this part for 0. This is sine 0. This need not to be written. Only this middle part will be substituted with 0. Others are 0. That's why I'm not even writing them. So 18 times x. That means it is also gone. So there is no need to write this. All three become 0. That's why I'm not writing them. Okay. So this is the only one. So 3 pi square sine 1 over 3 pi is square root 3 over 2. I know this, you can use your calculator. 18 x, it should be pi. 18 pi and cos 1 over 3 pi is half. There is something wrong here. This 3 sine 3x is positive. Why did I write negative here? I think I shouldn't have written negative here. So this is not negative. That means our this part becomes negative. Yeah, because of this negative which we borrowed from here. Okay, so it becomes 54 times square root 3 over 2 again. Alright, now final answer. Nothing is cancelling. So 3 square root 3 over 2 pi square, this is cancelling, plus 9 pi minus cancelling 27 square root 3. This is the value, exact value of that definite integral. I hope they have asked us the exact value also. See, this is exact value they asked. This concludes this solution video. I hope you liked it. If you did, give it a thumbs up and subscribe to Math United. Thank you very much.